So no, remember, we did this warm exercise for a reason. Everybody should still remember their unit circle, right? Yes? So, remember when we were dealing with polar coordinates, we dealt with an r and a theta, right? Now look at how would we change it from polar to rectangular.
There you go.
Okay, so we've got a point right here that is r comma theta, right?
I love those little dots there.
Change X to
But
R.
we don't, they're not really. Remember, they are r comma theta, they are a point. We're not talking about theta, something like theta equals pi 6. That goes on and on forever. This is a point. Just like rectangular, we had like 2 comma 3. So let's draw this.
Beautiful.
What do you notice?
You're right. Triangle.
The right triangle.
But there.
So if this is x, this is y. Remember, if you were writing rectangular coordinates, we could write this as x comma y, right? Yes? Okay, and it would be the same point right there where we went over x, up y. I'm doing the first quadrant, remember, it doesn't matter what quadrant I'm in, I can still do it, right? Okay with me? So now, how can I figure out what x is relative to r and y? Or r and theta, not r and y. Okay?
Log cosine.
Log sines, log cosines, we can use, but they're much more difficult. Okay, so we've got a right triangle. So, how would it, so what would we write? So, let's say sine of theta is equal to what? Okay, opposite over hypotenuse, y over r, and we can simplify that to y equals r sine theta.
But that would look like every single time that would be,
Yes.
would it be the same for everything?
Yes. Okay, how would we get x? Okay, same idea, so we could say cosine of theta equals x over r, so adjacent of our hypotenuse, and so you can say x equals r cosine of theta.
Does it ever ask for R? Would you use tangent?
Well, remember, when we're talking about, we have a polar point, which means we have an r and a theta.
Do we start with the polar point and never cross over?
No. So, we'll get to some other types, but this is our general conversion thing. It doesn't make sense that x would be connected with cosine. Okay, so you've got your unit circle. When we say cosine of 30 degrees, what are we looking for? X value at a 30-degree angle. So x and y deal with cosine and sine, respectively. Now, what could I do? How could we set up the Pythagorean theorem for this? What would we get? So these are 3 key things. You do need to know them, meaning those would be stuff you need to memorize, or know anyway. Know enough that you can generate them. Well, I'm not going to say you have to memorize them. However, you need to know them well enough that you can generate them from your mind. In other words, they're not going to be provided for you, and you'll need them. Well, I hate saying memorize when I'm not. This is stuff you already know. It's stuff you can generate without. Even if you don't memorize it, you can generate it very easily, just drawing the triangle. Now, we talk about tangents. What would the relationship with tangent be? The tangent of theta equals y over r. Yes, y over x. And we're going to put a restriction there when we're dealing with polar coordinates. This is for x greater than 0. We're going to use this one. And tangent of theta equals y over x plus pi if x is less than 0.
Where's the R?
Good? Is there an r when you deal with tangent? Alright, good. And let's see. So let's start with a couple of problems of this type. Convert, say, 4 comma pi 6. Change this to rectangular. What are we going to get? So y equals 4 sine pi 6. What's sine pi 6? 1/2. So 4 times 1/2 is 2. Okay, x. What's that going to be? 4 cosine of pi 6. What's cosine of pi 6? Root 3 over 2 times 4 gives us, so the coordinate would be 2 square root 3, 2. This is a rectangular representation of the polar point. Okay, these 2 points, this is a rectangular representation of this polar point. Are the same? Oh, they're the same coordinates, if that's what you're meaning. Meaning, if you had a rectangular grid and a polar grid overlaid on each other, these would generate the same points. Let's see, how about this one? -6, -120 degrees. What's it going to be? So everybody figured out we're doing this. We're going to do y equals -6 sine -120. What is the sine of -120? Negative root 3 over 2 times the -6 becomes 3 root 2. Is it positive? Or sorry, not root 2, root 3. 3 root 3. Yeah. Yeah, what's the sine of -120? Yeah, and negative root 3 over 2 times a -6. So, yeah, but -6 times a negative root 3 over 2. Negative rate cancel. 6 over 2 is 3. So again, we got positive y. Are we going to get a positive x? Doing the same thing. So what's the sine of -120 degrees? Or cosine? -1/2 times the -6 is 3. So we get the point 3 comma 3 square root 3. Did it work? Okay. Both positive points, which we expected because of where it's located. So checking this beforehand will help you say what should my answer be. And everybody remember how we checked it, or understand why we checked it that way? Okay, we said -120, so we went to down here, and then -6 says we're going up this direction, which told us both of them had to be positive. Now, if we're changing the other direction, change to polar. So here we were changing to rectangular, here we're going to change to polar. And let's say 8, 10. Okay, what? Okay, yes. So first, how do you get R? Yeah. We're just doing a squared plus b, or x squared plus y squared equals r squared, because you can do 8, 10. So r equals square root 164 which can be simplified to what? 2 squared root 41, is it? 2 squared root 41. Okay. Now theta. How are we going to get that? Yeah. Inverse tangent. So we can say tangent of theta equals tan over 8. So now we're going to tangent inverse. And that is something you're going to need a calculator for. Do 2 decimal places. So theta is approximately 51 point what? 34 degrees. So our coordinate would be what? Now, typically, if you have something like this, you don't want to just give the decimal approximation for here, because you've got here, it's hard to get the exact one. So, what? So, what is the decimal approximation of 2 root 41? If you put that in 12.81. Generally, you don't want to mix inexact and exact answers in that form. So, if you're doing a decimal approximation here, might as well do a decimal approximation there.
What if you put 51? If you put 51, there is one.
But 51 is even worse than 51.34. Because 51 is not exact. If we could put it like this: 2 square root 41, comma, tangent inverse of 5, 4. This is an exact answer, but this would be better in that sense.
You can decrease the radius.
It depends on what it asks. I mean, I like radians, but degrees and radians are equivalent.
But radius is always
Yes, unless you happen to be on one of the nice points. So this one is going to be a nice one, I believe. 1 comma negative square root 3. Change it to 4. What's an answer somebody got? Negative 60 degrees. Yep. So how did you get it? So 1 squared plus negative root 3 squared. That's easy. This is going to be 2. Then we can say tangent of theta equals negative root 3 over 1, which is a negative square root 3. And then,
Doesn't it have to be like high?
okay, what?
Does you use one of the formula units?
It said what?
One of the formula units is
So if x is greater than 0, x less than 0. Okay, and what do we get? We do tangent inverse.
Do you have to tangent inverse related cosine inverse with 1 over 2?
Okay, so you don't necessarily have to. However, remember the domain and range thing. When we talk about sine and cosine, sine and tangent did this part from here to here, whereas cosine dealt with this part. I think it was like beginning of chapter 5. So when you're doing or maybe it's when you're doing inverse sine, inverse cosine, inverse tangent. And so inverse cosine always gives something in this range, which means that we were down here, and that I think that might have been where you got the positive.
so you can't have 5 pi over 3
Well, you could put cosine of 5 or 2 put 5 pi thirds, so that's equivalent.
So is it have to always be tangent?
Yes. But also, remember, just keep track of where you're at. Make sure that your answer when it comes out, is the same as what you expected. Because these coordinates give the same location.
But I don't understand because like in the problem with negative 6, negative 120 at points instead of 1.
Let's see. negative 6, negative 120.
That's the quadrant one.
Yeah.
But then you had to say like the quadrant two and the equation. So it should be.
I'm not sure, what do you mean, I was in quadrant 2 when I was doing this?
Sine of negative, or I mean quadrant three, sine of negative 120 is fine.
Yes.
But the point is quadrant one,
And-
so where is it?
So I was just, yeah, remember the negative 6. So basically, we are plugging it in exactly as it was. However, because of the way sine cosine works, is it generates the point back in quadrant 1, which is what we wanted. We didn't have to change anything at all. We just plugged in exactly what we were given, r sine of theta.
So you can just ignore where it is and take the answer.
And then-
There is more stuff wrong.
Yes. What it's meaning is, we can use this as a quick check saying, does my answer make sense? It's not, how do I get the answer? It's, does my answer make sense, or where should my answer be? And since it should be fairly easy to go, like within 5 seconds, you should be able to look at this and say, this is what quadrant we're in. And therefore I know, am I Y or X? Now we're going to do the bit more difficult stuff. Connected.
What?
So our goal is, we want to change a rectangular equation into polar points. Or not polar points, a polar equation. We've got a rectangular equation, we want to change it to a polar equation. What is this the equation of? Circle. What's the radius? And how is it shifted? 3r. Okay, so we can easily graph this thing right here, where this right here is 6, middle is 3. And we want to write the polar equation for that.
For which
For the whole circle. For the equation.
What does polar equation look like?
R equals sine theta. Or R equals 2 cosine theta. Or R equals,
anything on the table here?
okay? Well, without using our equations that we've done, what can we do? What is x in polar form? What is it? R. What is x as in polar form? So we can say this is r cosine theta squared plus
R sine theta minus 3 squared.
equals 9. Okay?
Is that all you need to do?
No.
Oh, no.
Now solve for r.
No,
You have to do that.
Yeah?
You have to FOIL that? What?
So this one, let me see. It's going to be r squared sine squared theta minus 6r sine theta plus 9 equals 9. Why not? Okay? Well, let's subtract out the 9 easily, right? So those go away, so we're good. R squared cosine squared theta plus r squared sine squared theta. I'm going to put equals 6r sine theta.
1, that's 1.
But what's sine squared plus cosine squared? So I can factor out the r squared and make it cosine squared theta plus sine squared theta.
R squared.
Yeah. So this is all going to become 1, so we have 1 r squared, so we have r squared equals 6r sine theta. And what else? Divide by r. R equals 6 sine theta.
Can you square root and do half?
Okay, you do
Square-
that.
No, if you square root, it's going to be the same answer, right?
Well, it's not. There'll be equivalent statements, but we're still going to have R on both sides.
Yeah, but you can change that form into that, right? Can you show us?
No, I'm not going to do it that way.
Can you still?
Because that's messy. They're really messy.
Like, really?
Well, you're going to end up with R to 1/2, and you have to move it over, and then you have to square it to go back to what you were. You're basically, it's doing the problem in this form, where you have, say, x plus 7 equals 3x, plus 1, so we're going to do subtract 7, minus x, 0 equals 2x minus 6. Now I have to move the 6 back over. And that's basically the equivalent of what square rooting would do. You'd go past it and then come back, add in a few more steps. And messy steps, not nice steps. So you can choose to do that, but it's a very bad choice to do it. Okay. You good?
But isn't the...
So let's see, if we have theta equals pi third, take that to rectangular. And first, tell me about this graph. It's a line. Where does it go through?
0, 0.
Okay, we know it goes through 0, 0. What do we have to? What form would be the rectangular form of it?
Y.
Okay, we know it's going to be y equals mx plus b, where b is what?
Y.
0. So we know it's going to be y equals mx. So write the equation. Yeah.
Pi third.
And if you're at pi third, what is x?
Wait, what's the question of the change?
Okay, change to rectangular. So the coordinates we have on the unit circle would be what?
0. No, you need to go there.
On the unit circle, pi third.
1/2.
1/2, comma.
I think
Yes.
that's the full.
Yeah. So 1/2 root 3 over 2. How would you write these close up? We need a line that goes through that. And through 0, 0.
Square root of 3 over 2 over 1/2.
1/2, which is,
Square root of 3.
so our equation? Y equals,
Square root of 3x.
fairly simple, right? And the one that's nearly as easy, R equals 4.
X squared plus y squared is 4.
Yeah. Or how about one like this, where you have
What was the y equals
y equals, remember, we were just writing y equals mx plus b form. We know if we do the origin, this is 0 for b. We just had to get the slope. Well, not if it's in this form. If it's in this form, we can't get it. Remember, we had secant and cosecant, things get a bit more interesting. And yes, you can have some of them. So we'll get to some of those grids. Let's do r equals 2 sine theta. How are we going to do that one? Into rectangular form. Okay? What is sine of theta in terms of r? Y over r. So we can change this to r equals 2 sine theta over, or 2 y over r. Right? We can multiply by r, we get r squared equals 2y. What's r squared equal to? X squared plus y squared equals 2y. Now, if we want standard form, what are we going to do? Subtract 2y, x squared plus y squared minus 2y equals 0. What is the shape of this thing? A circle. So do you remember when you're dealing with our Conic. Complete the square with y. X squared plus, what number are we going to have to add?
No.
1. Because negative 2 divided by 2 and squared plus 1. We get y minus 1 squared equals 1. There we go.
I was sure you were trying to do this.
What?
I didn't really-
Okay, we were told with writing this form.
What did you say?
So we started up here with r equals 2 sine theta.
How did you?
So first thing we want to do is change sine into y over r, and then multiply by r to get r squared, and then change r squared into x squared plus y squared.
Why did you want R to go there?
Because then r, we get the equation says r squared equals x squared plus y squared.
R to go.
X squared plus y squared equals r squared.
So why do you want R to go?
So we can replace it with x squared plus y squared. Because remember, if we're changing to rectangular, we can't have r's or thetas at all. Yeah.
Oh. Can you have to show the work on this, we can't tell what.
Yes, that'll work. And we're going to do one more that's a bit more complicated. Although not a significant amount more, it is a bit more. Ready? Good. R equals 1 over cosine theta plus sine theta.
Let's change it to rectangular.
Yeah, change to rectangular.
Together?
Okay, what do you think? What should you do? What do you think? What? Okay, that's one idea. Well, what? He said convert these to like sine over r, cosine over r, or y over y over r and x over r. Possibly. There might be some stuff in there. And that's what I would suggest doing, is multiply both sides by cosine theta plus sine theta. Why would I do want that? And notice, what is this going to be distributed to become? Yeah, so we've got x and y right there. And then we can put y equals, change to y equals mx plus b form.
Do you have cosine?
Wait,
Do you have cosine theta plus sine?
Can you finish the problem?
No.
I actually don't see it.
Okay, look at it then. What's r cosine theta equal to? Okay, and then what's r sine theta? Okay, then look at your notes.
What do you have cosine theta plus sine theta?
Right here? Oh, here?
Yeah.
Why? Remember, if we had, say, 4 over 3, multiplied by 3, I don't become, this is not 12. Because it's just a 3 and a 3 cancel.
Oh, right. This is 12 over
12 over 1, or 12 over 3.
So you have 4.
12 over 3 gives us 4, which is just what we have on top already.
Are there any?
Oh, yeah.
Or height? I know.
Possibly. So let's see, step more difficult. R equals, let's see, -2 secant of theta minus 11 pi over 6. And change it to rectangular. So this is going to be drawback on what your trigonometry skills that we had earlier this year. So Adam was saying convert to cosine. And so what do I get?
follow him. Oh, he was.
I get r cosine of theta minus 11 pi over 6 equals negative 2. Yeah.
Can you distribute cosine and theta? Cosine is not multiplication. Distributive property is only multiplication. Okay? What ideas do you have? Yes, but we don't have r cosine theta. Any ideas? Anybody? We have some in different formulas. Remember that? Now, I don't know if that's the best way, but if you get stuck and to start looking at what things have we done before. So we've dealt with some in different formulas. If there was a different formula for cosine, then we had cosine of a minus b. Cosine a, then it's cosine b plus sine a sine b. If I remember correctly, that's it.
Yeah.
I'm not sure. I just think if I'm remembering correctly, that's what it is. These were not ones you need to have memorized. No. So let's see. Anybody want to check? Go back and check. Okay, I want to make sure we did these right. Okay, chapter 5, I think. Sorry. It is? Okay. Okay, so this would become r cosine theta cosine 11 pi 6. So I'm going to put that in here, plus sine theta sine 11 pi 6. Yeah, this is going to be the way you have to do it. I don't know if this is my first thought when I was doing that. Is that there might be another way that might be simpler, but I'm not something I think of. But you know, we get r cosine theta right here, and then we'll get r sine theta there, right? Then we distribute that r. So what is cosine 11 pi 6? Okay, so we're going to get x square root 3 over 2 from that. Everybody see where that came from? Yep. Okay, r cosine theta. When I distribute this r there and r there, so it'll be r cosine theta, r sine theta, plus y, what's sine of 11 pi 6? And times negative 1/2 equals negative 2. I would like that. The x root 3 minus y equals negative 4. And our goal is getting y by itself. So y equals square root 3x plus 4.